Okay, so what I'm going to do is grab your chapter 6 assignment for a second, okay? And Mary, I'm going to use yours just to go through where your errors were. Okay, so starting on question 3. Okay, it says rewrite the trig expression in terms of sine or cos or both, then simplify it. Okay, so the first thing that I'm going to do here is I'm going to change this to cos right off the bat. So I have 1 over cos squared x minus sine squared x over cos squared x. Okay, now I've got a common denominator already, so I can put it all together, and I get 1 minus sine squared x over cos squared x, like that. And then I notice that 1 minus sine squared x is the same as cos squared x. So I change that to cos squared x. So now I have cos squared x over cos squared x, which is 1. So that expression actually reduces down to 1 there. Okay, so you did the right thing to start with. You did everything right except for you didn't write cos squared x. You wrote cos x over cos squared x.
Yeah.
Okay.
I guess.
So you were good. You were good right up to this point right here.
Yeah.
Okay. All right. The majority of you on the next question lost the mark because you're working. It was chicken scratch for most of you. What you have to do when you're asked to verify the potential identity, you have to draw a line down and you have to work with it that way. So I have cos x over 1 minus sine x equals 1 plus sine x over cos x. Now what you need to do is you need to do this. You have to draw a line down and you work, you plug your values in and you work on both sides. So they wanted you to put in 30 degrees, so I go cos 30 degrees over 1 minus sine 30 degrees, 30 degrees. Okay? All right? So cos of 30, root 3 over 2 over 1 minus a half, 1 plus a half over root 3 over 2. So this is root 3. This is root 3 over 2 over a half. This is a half over root 3 over 2. So when I multiply these, I get root 3 over 2 times 2 over 1, which is root 3. When I multiply these two, I get a half times 2 over root 3, which is 1 over root 3. I've got something wrong here. My bad. This should have been 3 over 2 right here. So I get 3 over root 3 right here. When I rationalize that, that gives me 3 root 3 over 3. Right? Which leaves me with root 3 here, and then I put equals in there.
I think I put equals in the whole entire time.
Yeah, which is what we call a concept error, which is 1 mark off.
Okay, so I have to draw a line next time.
You have to draw a line. You only put equals to on your first statement and your last statement, and that's it.
Okay, so first statement.
Okay? All right. The next question was sine 25 cos 65 plus cos 25 sine 65. That is the sine of 25 plus 65. So you had your identity wrong there. You use subtract, which when you did it your way, so that gives me sine 90.
But it says minus in the thing, like on the identity sheet, it says sine A minus B is equal to sine A cos B minus cos A sine B.
Right, but your question is sine cos plus.
Oh, so it's all reverse?
No, for that one it's still the same, right? Like your identity is this. Sine alpha plus beta, or A plus B, right? Is sine alpha cos beta plus cos alpha sine beta. And the order of these guys doesn't matter. But you have to have a plus there.
Yeah, I see it now.
Okay? Now, for cos though, on the cos one, it's the opposite. So you did that right again. So I should have had cos pi over 6 plus pi over 12, which is the same as the cos of 2 pi over 12 plus 1 pi over 12, which is the cos of 3 pi over 12, which is cos pi over 4, which is root 2 over 2. Okay? All right. And the last one I'll look at is the one at the very bottom, the last question, 9b. So 9b, I've got cos x tan x minus sine squared x equals 0. So if I switch this to cos x, and then this is sine x over cos x, okay, those cancel, leaves me sine x minus sine squared x equals 0, sine x, 1 minus sine x equals 0, sine x equals 0, sine x is equal to 1, x is equal to 0, 90, 180. And your solution. Okay. Justin, I see you on here. Oh, maybe you went off there already. Rats. Okay. Hopefully he'll be on in about half hour. Just want to send a message to him. Okay, that's the assignment. Everything else, most of you got it right. All right. I want to take a quick look at 7.2. Okay, 7.1 you guys made out okay on? So 7.2 goes back to our transformations again. So now that you have your basic graph, your basic graph like 2 to the x, we know what it looks like. Okay, so we'll start with that. That's our basic graph. Just a second, I want to make sure. Okay. All right. So now today we're looking at this. Y equals A. What do they use here? C. They use this. So then I've got B, X minus C plus D like that. Okay. They use H and K, but we're going to keep it consistent to what we've done always to this point. So what does A do, or what does A do to the graph? Or what do we do with A? What does the A do to a graph?
It by all the y values.
That's right. Multiply your Y values. B is what?
Multiply your x values.
By B?
X values.
Say that again?
Isn't it 1 over?
Yeah.
1 over your x.
Multiply X values by 1 over B. Okay. C, move left or right. D, move up or down. Okay, so the same thing occurs. Now we've done this now for polynomials, we've done it for rationals, we've done it for trigonometric ones. Now we're going to do it for exponential ones. Okay, so let's look at your example on the first one. It says consider the exponential function y equals 2 to the x. And then what happens to the graph? State the parameter, describe the transformation, and so on. So, okay. So, y equals 2x plus 3. So what am I doing with the graph now?
Extending it. Well, put it up 1 first of all. Up 3, so.
Okay. Not first of all, it's the only thing you do. Right? So this coordinate right here is 0 and 1, right? That's our typical intercept for an exponential function. Now it moves up 3. Our asymptote, which we don't normally, we need to draw in, we have to remember to draw it, also moves up. Okay? So we're going to move everything up 3. So I go to 0 and 4, and then my asymptote goes right here. So everything moves up 3. Okay? We're all right? Now, the beauty of this right here is that you've only got one real major, well, two major coordinates, one coordinate and one line to consider. Your asymptote is important. It has to move if you're moving up or down. And your intercept is the one that has to move. So what happens? y equals 2 to the x minus 5. What happens to my graph now? This is B on your book, 289. 239, sorry.
It would reverse because when you do an exponent of a fraction, or no, 5, so it would be a negative.
Okay, let's look at our base. Okay, x minus c. What does the c do to the graph? Moves it left or right. Okay? So now, what happens to this graph?
Left 5.
Right 5?
Right 5.
Oh.
Because it's beside, remember I know there's no brackets in this, so we have to know that it moves to the right 5. Okay? All right. Let's look at the next one. See if we can get it right. So I'm going to move that 4 over. So I have this. Excuse me.
So you'll move left 1 and then up 4?
That's correct. Mary, you follow that? Yeah?
Yep.
Okay. All right. Oh, and they give you huge explanations on it on 240 and 241. So if you wanted to go through all of that, you're welcome to. Okay. Let's look at the most difficult one that you can see. So let's go to example 3. And I have this. Yeah.
Are you still posting live on YouTube?
Yeah.
Or did you stop doing that? Oh,
Nope.
because for yesterday's thing, I think I didn't see it anymore.
It should be on there. Although I'm a little concerned because I noticed my 10 o'clock one from this morning has disappeared somehow. So I'm going to look, I'll look again, but they were all on there this morning from yesterday.
Okay. Because I checked yesterday night and I couldn't see it anymore.
Right.
Maybe it's back on top.
Yeah, I'm not sure. It seems to be coming and going. I don't know what's happening. All right. So the first thing that we're going to do the same thing that we did with rational functions. We're going to do the same thing that we did with trig functions. Okay. The first thing we're going to do is write out what A, B, C, and D are. Because they're wanting us to graph this. So we're going to write this out. So what is my A value?
-4?
No. No.
Or is it 1/3 of 4?
Sorry, say it again, Dylan.
Is it 1/3 of -4?
No, no, no. Let's go through this slowly. Again, this is my do it like this. Okay. Let's try it again. Okay. I sneeze again, sorry. What's my A value?
-1?
Yeah. What's my B value?
1/3.
Yeah. C?
2.
Say again?
Isn't it 2?
No,
2 to the left.
minus 2, yeah. And my D is?
0. Oh no.
Like 1.
Oh yeah. I was looking at the last half of that.
So what would 4 be in that scenario then?
4 is my base for my my exponential function.
Oh, I remember that now.
Oh, okay.
Oh yeah, that makes sense.
Okay? All right, so I'm going to rewrite these out right here. -1 here, just like that, okay?
1/3, -2. Your H is your C, right?
Yeah.
And your D is your K.
Yeah, that's right. I try and keep it consistent to our trig stuff. So, okay, so now that I have that, all right, now my equation, the original equation was y equals 4 to the x.
Yeah.
Which means that this still is 0 and 1 right here, right? So far? I'm just graphing this. So this is the graph of y equals 4 to the x. Okay, so now what I'm going to do is my focus is going to be on just that 1 for a second. Okay, that 0, 1. I'm going to look at this coordinate right here. All right. Now, what does my A do to the graph?
Multiplies your.
Minus the y values.
Yeah. Now, if my
Flips
A,
it over to x-axis.
yeah, okay. So let's talk about that. There's 2 ways to do this. Remember, the first is to multiply your y values by negative, and -1 in this case. Okay. The second thing to do is to say, hey, it's a reflection over the x-axis, right? So this is the first thing that happens. So that 0, 1 becomes 0, -1. And all of my y values that were positive are now negative. Okay? Everybody's all right so far? Okay. Now, what does my B do to the graph?
Multiplies x values by 1/.
Yeah. So what's 1/b in this case?
3.
3. That's right. So I would multiply all my x values by 3. Well, let's be honest, it's not going to affect you a whole pile. It may look a little bit steeper. Which way would it go? This would be here. It'd be less. So it might look something like this. I don't draw this second part in here. So something along that lines, okay? You would extend it out because you're multiplying your x's by 3s, but don't draw that one in. Because realistically, when you're multiplying 0 by 3, what do you get?
0.
0. So that doesn't change it. Now, the thing that affects, so most of the time, sorry, I keep cutting in and out. Is everybody back on? We're good? Okay, so normally the AB graph, the A's and the B's, they affect it greatly. But in this case, there's not as much of an effect. The effect on this graph usually comes from C and D now. Okay, so I'm going to shift now my C value. So I'm going to move my coordinate to the left 2. So this now comes over to here. Let me do black. So that 0, 1 becomes -2 and 1. Like that. Okay? And then I'm going to also go down 1 to right here. So this coordinate has moved 0 and -1, has moved left 2 to -2, -1, and then down 1. So it's now -2, -2. As well, my asymptote has to come down 1. My asymptote comes down 1. Now here's the catch. All right, I'm going to sketch this. So I'm going to redraw my sketch. What you need to find from this equation. So this equation was y equals -4, 1/3 x minus x plus 2, subtract 1. What you want to do is you want to find out what the y-intercept is. Okay? So I'm just going to move this over. I'm going to rewrite my equation. Y equals -4, 1/3. So I'm going to put 0 in for x. All right. So my y-intercept is -4, the 2/3, subtract 1, and leave it like that. If I could break it down a little bit, I probably would, but I'm going to leave it as is. So there's my y-intercept. So that's the one thing that they really want you to be able to calculate from this question. That's the one thing that is a lot of work. But really all you're doing is putting 0 in for x and solving for y. And you don't have to simplify it. If you can simplify it, great. If you can't, so be it. Okay?
Mr. Newton.
Yeah.
Dalen and I have a test in calculus that started at 11:25, and we only have till the end of period 3 to finish it before it locks us out.
Okay.
So,
Well, I'm going to work on physics right now. So I will leave this up live. Mary, you still with me? You good?
Yeah.
Okay. So I'll work with Mary. I'm going to try and get a hold of Justin, and I'm going to do some physics right now. On those.
Me too.
Yeah, I will. Do you have any questions off of those 1 to 18 you want done?
Could you do, I think it was like questions
17.
Or
Yeah.
question 8.
Question 8?
Yeah.
Question 8 and question 17, you want those done?
Yeah.
Okay, I'll leave it up on YouTube for you.
Thank you.
Thank
Okay,
you.
yeah, no problem. All right, Mary, see ya. Mary, I'm going to just see if I can get a hold of Justin here. He was on earlier.
Okay.
So I'll see if he connects. Hi, Justin, are you on there now? Perfect. Okay, you can, if you have anything you want to add, you can, there you are. Talk to me, Justin.
Yeah.
Hey, I can hear you.
I can hear you.
Okay, perfect. We're gonna go through questions in our textbook on so 1 to 18 on page 457. Justin, have you started it or not?
I started with 2 then.
Okay. All right. So I'm gonna go through Dalen and Brendan. They're not on. They had to do a calculus test. So I'm gonna go through question 8 and 17 right now, and then if you and Mary's on with you, I don't know if you can see her. if you have any questions you want me to add to today's, I can do that. And then I'm going to post an assignment on here for you, 3-question assignment that you'll do for Monday. Okay? So if you don't have anything you want to add, just mute your microphone, and then when you want to chime in, just chime in. Okay? Okay. So I'm looking at question 8. Actually, I just want to save the material here. Okay, so question 8. It talks about a battery has an EMF of 26.4 volts, an internal resistance of 0.3 ohms, a load resistance of 3 ohms, and is connected across the battery. And then it asks how much power is delivered to the load and dissipated in the battery. Okay, so I don't need to do this, but I'm going to do this just so we have an idea. So I have a battery that has an internal resistance, and then I have a load resistance connected to the outside of it. Okay, so again, I like my charts. Charts seem to make it better for me to make it make sense. So I'm going to put my resistance, and then I have Ohm's law, which is VIR, and then power. Okay, so I have my resistance here. My internal resistance is 0.3 ohms. My load resistance was 3 ohms. And I had a total of 26.4 volts. Okay? So what we said is if we were given all our resistances, the first thing that we would do is find the total resistance. Now, again, it's not necessary, but we do need it for this question. So that's the way we're going to approach it. So I have 3.3 ohms here. Okay, so now I have my total ohms, my total resistance. I have my total voltage. I can now calculate what my total current is. So I calculate my total current by dividing, and I get 8 amps. All right, so now that I have 8 amps, I know that that current is leaving the battery with 8 amps. And going all the way through here with 8 amps. So I know that this has 8 amps and this has 8 amps. So if I were wanting to get the total voltage on each, I would multiply 24 volts here, and this would be 2.4 volts here. So that would be where we would leave off in the last unit. But now we need to know what the power is in it. So we want to find out the power dissipated in the internal resistance, in the battery, in the load resistance as well. So about 2.4 times 8. So this guy, I'm going to put that in green, is 19.2 watts. This guy is 192 watts. All right, and if I wanted to figure out what the total was, I would add those together, which would give me, what is that, 19, so that's 211.2 watts. So that's the power that's dissipated. So dissipated means basically being used up or being utilized. So the power in the internal resistance is 19.2, and the load resistance is 192 watts. And that basically takes care of what they were asking in that question. Okay? Give me a second to copy that down.
Mr. Newton, I can't see your screen.
You can't see my screen?
No.
Okay, so how do I do this? Okay, put your camera on yourself, Justin.
Okay.
Try it this way. Okay, great. So now I can see your ceiling at least. So that's a good start. Okay, you still can't see the screen?
No.
Okay, let me try something else then. I'm not sure why. I'll shut my camera off and turn it back on. Okay, Mary, you can see it. You're okay, Justin?
Yeah.
Okay. Sorry. Okay, so do you...
Same thing where you just had power.
Yeah. Yeah, that's right.
Okay, and the power is.
You have 3 different equations for power. We can use VI. We can use I squared R. Or we can use V squared over R. Depending on what you're given. And you can use all of them. You can use one of them. It doesn't matter which one. Those are when you're working with volts and current and resistance. Okay?
Yeah.
You got her down?
Yeah.
Okay. Let's look at 17 now. It says how many meters of number 30 gauge nichrome wire? So we need the length. We have 30 gauge nichrome wire are needed to form the heating element of 1,000 watts. Oh. So, sorry. Okay, so I've got to form the heating element of 1,000 watts. So my power is 1,000 watts. The volts is 117 volt line. Okay, so what I need is to work with resistance. All right. So resistance is equal to my rho constant. So that again is from the back of the book. And I've got L over A. So to get my L, that's my resistance times my cross-sectional area over my rho constant. So the first thing that I need to do is I need R, I need A, and I need my rho constant. So what I'm going to do is solve for R first. So power is equal to V squared over R. Therefore, R is equal to V squared over P. So we're going to take 117 squared and divide it by 1,000. And I get 13.689 ohms. Okay, so that's my resistance. So now I have to get my A and my rho. So I have 13.689. Now I go to the back of my book and I have to find out what my cross-sectional area is for 30 gauge. So I go to 677 and my cross-sectional area for 30 gauge is 0.5093, and that's in millimeters squared. So I have to divide that by 100. Okay, that's in millimeters squared. So I'm going to divide that by 100 to get
Do you have
it.
the right number there? Is it 0.0593?
I thought so. Let me have a look. So 30 gauge It's 0.05. I see. Sorry. Thank you. Yeah. 0.5093, like that, right? Okay. And then on the page before, we need to find out what my resistivity constant is for nichrome. So I look at nichrome, and it is 115 times 10 to the negative 6. And that's ohm centimeters. Okay. So now let's punch that into our calculator. Is that what you get?
I can't see it, but I got 60.64.
Okay, I have 606. Let me have a look and see which one of us has the decimals off.
It's 0.606 meters. So.
Okay, what did we do wrong here?
Would it you divide by 100 or by, if it's in meters?
What? It's in, oh.
Yeah.
Oh no, okay, sorry, this is, my bad. This is centimeters then. My bad, sorry about that. Man, tough day already. This is in centimeters here, right?
Okay, so if I change it to meters, like I get the right answer.
Yeah. I've got my decimal wrong here. This should be 60.6244, like that, centimeters, and then I end up with 0.606244 meters. That's my answer. Okay?
Can we do in?
Yeah, I just want to check and make sure you got that right. Justin, are you okay on that guy?
Yeah.
Okay, perfect. What number did you want to do, Mary?
Yeah, 18.
18 now? Okay.
I just don't know where to get the
Okay, so, all right, so here's what happens, okay? When we started all of this, we started with coulombs, and then we did coulombs per second, which was amps, okay? So I go from an amp, which is coulombs per second. When I find out the number of coulombs going through over that amount of time, I get coulombs, and then from coulombs, I get electrons. Using my conversion. So the first thing I want to do, Mary, is I want to find out my amps. Okay, so I have a 117 volt line dissipating 100 watts. So my I is equal to P over V. So take 100 watts divided by 117. So that's amps. So I've got 0.8547. So amps, Mary, are coulombs per second. Amps are coulombs per second. Okay? And it says through a day. So I need to find out how many. So I have 24 hours, right? Times 3,600 seconds in an hour. So I need the times 0.8547 by 24 and then by 3,600 to find out how many coulombs go through in a day. I get 73,846.154 coulombs. Okay. Now that I know the number of coulombs, I need to convert that to electrons. So how many electrons in 1 coulomb? You have your formula sheet there?
I actually don't have that written anywhere.
Do you have your formula sheet?
Yeah.
Okay, go on your formula sheet. What happened? Yeah.
I should print it. I'll find it.
You don't have it?
No. Well, I might. Actually, I should check that.
Well, it's not a big deal. I'll find it for you. I just was wondering if you had it. So there's 6.25 times 10 to the 18 electrons. 6.25 times 10 to the 18 electrons in 1 coulomb. So you take that number, times it by 6.25 exponent 18. .6154 times 10 to the 23rd electrons. Okay. All right. So this all started. We're working backwards from what we have done so far. So we started with electrons to coulombs to amperes to power. Now we're working backwards. We're going from power and voltage to current to coulombs, and then we find the number of electrons at that point.
Okay.
All right?
Yeah.
Okay. Any other questions, Mary?
Maybe 13.
Sure.
I don't think I got it.
Okay. An electric iron has a mass of 1.5 kg. So I'm going to use 1,500 grams. The heating element is 2 meters in length. Rarely do I use centimeters, but I'm going to. Number 24 gauge nichrome wire. So we know our rho constant is 115 times 10 to the negative 6 ohm centimeters. Our 24 gauge wire gives us our cross-sectional area. What's 24 gauge?
24 is 0.2047.
Right? So I've got 0.2047 divided by 100, right?
Yeah.
To get me centimeters squared. Okay, because it's in millimeters squared, right?
Yeah.
Right. Okay. And there's 10 centimeters and 10 centimeters. All right. So there's that. So what do these three things give me here?
Your power or your watts or something. I forget the equation. Or your resistance.
Resistance, so that's exactly correct. So I get my resistance from there. So that's important to know. All right. Now it says what time is required for the iron to be heated from 20 to 150 across a 115 volt line. Okay, so my voltage is 115. And my change in temperature is 130 degrees, right?
Yeah.
And now here's a new one for you. Here's a new one for you. I need the specific heat constant for iron. So you find me the specific heat constant for iron.
Not the melting point.
No, specific heat constant. So that is, look at page 674 and your heat constants.
It's 0.1075.
That's right. So this is 0.1075, and that's calories per gram degree Celsius. Okay? All right. So it is asking us for the amount of time again. So this is another one of those questions. I have Q equals I squared RT over J. So my time is equal to I squared R. My time is equal to Q times J over I squared R. This is a Q. All right. So looking at the board right now, I need an I need an R, and I need a Q from this information right here. Okay? So the first thing I'm going to find is let's get my R. So my R right here comes from, we're just going to use this part of the board to, my R comes from the rho L over A. So let's get my resistance. So my rho is 115 negative 6 times 0.2047 divided by 100. And then that's all divided by, oh shoot, 115 negative 6 times my L, which is 200, divided by 0.2047 divided by 100 equals. So I get my resistance to be 11.236 ohms. Okay, so I'm using these three right here and putting them into that equation. You follow that?
Yeah.
All right. Justin, you follow what I did there?
Yeah, you just put, to get R, you just did 115 times 10 to the negative 6 times 2,000 divided by A.
200. 200 divided by A. So yeah, you're right. Yeah. Okay. So now that I have R and I have V, I can get my I next. I is equal to V over R. So let's find out what our I is. So I take 115 divided by 11.236, and I get 10. 235 amps. Okay, it's a long question. It's a good question though. Following so far? Mary?
Yeah.
Okay, so now the next thing. So now I have I have R, I have J. So the last thing that I need in that equation is a Q. And my Q is the amount of heat required to raise the temperature of that iron 130 degrees. So my Q is equal to 1500 times my C, which is 0.1075, times 130. So I'm using MC delta T. So my M is at the top. It goes with C and T. So my heat is 20,962.5 calories. All right. Okay, so now I have everything I need. So the last thing I want to do is T equals QJ over I squared R. So 20,962.5, 4.19 joules per calorie over 10.235 squared times 11.236 ohms of resistance. Okay. Remember to use brackets on the bottom.
I got 74.622.
Excellent. So did I. Okay. That good?
Yeah.
All right. Okay, so I will post an assignment in both your classes right away, Mary, and Justin. I'll post a 3-question assignment on Edmodo. So if you can print that off and email it to me back Monday, by Monday, that would.
Yes.
Okay. Did you have any other questions, Justin? Are you okay?
No, that summed it up.
Okay. Perfect. Right on. Okay, well, have a good weekend. I'll see you back on here at 11 o'clock on Monday.
Okay, yeah.
Okay, talk to you later. What's that, Mary?
Can I ask you something? It's not about math.
Yeah, go ahead.
How do you, like, with YouTube, do you broadcast